Hello everyone, I welcome you all to this session. In today's session, we'll discuss some of the problems on model question papers. In the last session, we discussed about transform analysis of LT system. So there we have discussed about transfer function, difference equation, then causality and stability conditions. Then you solve the problems related to difference equations and all. Yeah, we'll discuss some of the problems of model question paper. This question is appeared in model question paper 1. Determine the transfer function and the difference equation representation of an LT system described by the impulse response. Here h of n is equal to 1 by 3 to the power n u of n plus 1 by 2 to the power n minus 2 into u of n minus 1. And here I have to obtain the transfer function and the difference equation. The transfer function means I have to obtain h of z. By using that h of z, I have to obtain the difference equation. Now, given the given impulse response, the h of n is given. The h of n is equal to 1 by 3 to the power n u of n plus 1 by 2 to the power n minus 2 to u of n minus 1. So I'll write this as 1 by 3 to the power n u of n plus, I'll expand it, I'll get 1 by 2 to the power minus 2, so it will be 4. 4 into 1 by 2 to the power n u of n minus 1. Now z transform of h of n is given by, I'll write h of z is equal to summation over n from minus infinity plus infinity, h of n z the power minus n. Now I'll substitute for h of n, so h of n is given here, I'll write this h of n, that is 1 by 3 to the power n u of n plus 4 into 1 by 2 to the power n u of n minus 1 into z the power minus n. And now I'll write separately, that is because of this u of n, I'll write this as n is equal to 0 to infinity 1 by 3 to the power n z the power minus n plus 4 into the summation from 1 to infinity 1 by 2 to the power n z the power minus n. Now this can be written as summation of n is equal to 0 to infinity 1 by 3 z inverse to the whole to the power n plus 4 into summation over 1 n is equal to 1 to infinity 1 by 2 z inverse to the power n. Now by using infinite series summation equation, I can write this as h of z is equal to 1 by 1 minus 1 by 3 z inverse plus 4 into here the lower limit is 1, so I can write from 1 to infinity it is summation over 1 to infinity a to the power n is a divided by 1 minus a. So I will substitute that equation 1 by 2 z inverse divided by 1 minus 1 by 2 z inverse. And I'll simplify this 1 minus 1 by 2 z inverse plus 2 z inverse into 1 minus 1 by 3 z inverse divided by the denominator, that is 1 minus 1 by 3 z inverse into 1 minus 1 by 2 z inverse. So I'll multiply it, I'll simplify this. So I'll get 1 minus 1 by 2 z inverse plus 2 z inverse minus 2 by 3 z to the power minus 2. The denominator I'll get 1 minus 1 by 2 z inverse minus 1 by 3 z inverse plus 1 by 6 z to the power minus 2. So finally for my transfer function I'll get 1 plus 3 by 2 z inverse minus 2 by 3 z to the power minus 2 divided by 1 minus 5 by 6 z inverse plus 1 by 6 z to the power minus 2. This is a transfer function. Now by using this transfer function I have to obtain difference equation. So obtain a difference equation, I'll write this transfer function as ratio of output by input, that is y of z by x of z is equal to this 1 plus 3 by 2 z inverse minus 2 by 3 z to the power minus 2 divided by 1 minus 5 by 6 z inverse plus 1 by 6 z to the power minus 2. So cross multiply this, y of z into the denominator 1 minus 5 by 6 z inverse plus 1 by 6 z to the power minus 2 is equal to x of z into 1 plus 3 by 2 z inverse minus 2 by 3 z to the power minus 2. So I multiplied y of z. So y of z minus 5 by 6 z inverse into y of z plus 1 by 6 z to the power minus 2 into y of z. The right hand side will get x of z plus 3 by 2 z inverse into x of z minus 2 by 3 z to the power minus 2 into x of z. Now by taking inverse z transform, you know that the z transform of y of n minus 1 is z inverse into y of z. So if I take the inverse z transform of this particular term, I will get y of n minus 1. Therefore, by taking the inverse z transform of this, I will get y of n minus 5 by 6, y of n minus 1 plus 1 by 6 because of z to the power minus 2, y of n minus 2 is equal to x of n plus 3 by 2 x of n minus 1 because z inverse into x of n minus 1 minus 2 by 3 x of n minus 2. So this is my difference equation. Observing the past value and the past value of input and present value of input and value of output, that is y of n minus 1, y of n minus 2, n minus 1 and x of n minus 2. Now from given h of n, I am obtaining a transfer function. Then by using a transfer function, I have to obtain the difference equation. A discrete time LT system is characterized by following difference equation: y of n is equal to y of n minus 1 plus y of n minus 2 plus x of n minus 1. Find system function, indicate ROC if system is stable, indicate ROC if system is causal, obtain impulse response in both the cases. And this question is appeared in model question paper 2. And I explained this problem in the last class, the last session. And here, this problem is very important, and this question is asked for 10 marks in model question paper 2. And this question is appeared in most of the old question paper also. So here, first you need to find a system function. To obtain a system function, first I have to apply the z transform on both sides for the given equation. From that you will get h of z. Then you have to define whether the system is stable, whether the system is causal based on the ROC. So here I will write y of n minus y of n minus 1 minus y of n minus 2 is equal to x of n minus 1. Taking z transform on both the sides, we get y of z minus z inverse into y of z minus z to the power minus 2 into y of z is equal to z inverse into x of z. And here y of z is equal to 1 minus z inverse minus z to the power minus 2 is equal to z inverse into x of z. From this I will obtain system function. The system function is also called as transfer function. H of z is equal to y of z by x of z, that is equal to z inverse divided by 1 minus z inverse minus z to the power minus 2. Now if I will solve this equation, this is a quadratic equation. If I will find the roots here, I will get the roots are minus 0.62 and plus 1.62. So if I write in terms of positive powers of z, this h of z looks like this: z divided by z plus 0.62 into z minus 1.62. So write this equation as 1. You have to define the ROC for the system to be stable, and for the stable condition, you already defined it. For the stable, in terms of ROC, it must include a unit circle. H of z must include a unit circle. To include the unit circle in the ROC, and I have to consider the condition. There are two poles are there. One is at 0.62, other one is at 1.62. Suppose if I consider z is greater than 1.62, then the unit circle is not included in the ROC. Therefore, I will consider the ROC as mod z is greater than 0.62 and mod z is less than 1.62. If I will combine this, then I will get mod z is greater than 0.62 and less than 1.62. Now I will draw a two circle with a radius 0.62 and 1.62. The two poles is mentioned here, 0.62 and 1.62. And this is my ROC, right? between the two circles. It is a concentric circle, it is ROC. And if I draw a unit circle, the unit circle will be within this, because this is 1.62 and this is 0.62. So I can draw a unit circle as this. So ROC is here in the ROC, the unit circle is included. So this is the ROC for the stable system. Similarly, if I'll consider a system is causal, for the system to be causal, ROC must be outside the outermost pole. And here the outermost pole is 1.62 and ROC I will consider outside that. So this is my ROC here. I draw a circle with a radius 1.62 and ROC is outside the circle. Therefore I can define the ROC as mod Z is greater than 1.62. So the two ROCs for the system to be stable and causal. Now the last condition you have to find out here, you have to find out the impulse response for system to be stable and system to be causal. Now to obtain the impulse response, I have to use h of z equation. So from equation 1, I can write h of z is equal to z inverse divided by 1 plus 0.62 z inverse into 1 minus 1.62 z inverse. Now by applying partial fraction method, I can write h of z is equal to a divided by 1 plus 0.62 z inverse plus b divided by 1 minus 1.62 z inverse. You know how to find out the values of a and b. I just cross multiply it and then substitute z inverse is equal to 0.62. I'll get b is equal to 0.45. Similarly, put z inverse is equal to minus 1.62. I'll get a is equal to minus 0.45. So therefore h of z I can write it as minus 0.45 divided by 1 plus 0.62 z inverse plus 0.45 divided by 1 minus 1.162 z inverse. So this you consider it as equation 2. Now you know that for ROC for a stable system, I written it as mod z is greater than 0.62 and it is less than 1.62, right? So now taking inverse Z transform of equation 2, I'll get impulse response. This h of n is given by minus 0.45 and here this is z mod z is greater than 0.62. So the first term will be a right sided sequence here. Therefore minus 0.62 to the power n u of n. And second term is a left sided sequence, so this will be a minus here. The minus 0.45, 1.62 to the power n u of minus n minus 1. So this is left sided sequence because the ROC is less than condition here. So this is the impulse response for the stable system. For a causal system, we have defined the ROC is mod z is greater than 1.62. Now taking inverse Z transform this equation, we get h of n is equal to minus 0.45 into minus 0.62 to the power n u of n plus 0.45 1.62 to the power n into u of n. Here both are right sided sequence because ROC is greater than condition, so you have to multiply with the u of n. This is about the impulse response calculation from the system function. The system to be stable and the system for the causal system. So next we will discuss the problem on properties of Z transform here. Find the Z transform of the signal x of n is equal to n into minus 0.5 to the power n u of n convolved with 4 to the power n u of minus n. This appeared in model question paper 1, and here this is a convolution operation, and you know that there is one property of Z transform, that is a convolution property. The convolution in a time domain is equivalent to the multiplication in a frequency domain. Now before applying convolution property, I have to obtain the Z transform of this first term, and at the same time I have to obtain the Z transform of the second term. Then I'll apply the convolution property. Now I'll write x of n is equal to n into minus 0.5 to the power n u of n convolved with 4 to the power n u of minus n. Okay, first you find the Z transform of w of n. I'll take this as w of n, the signal. Anything you can consider, you can use it as x1 of n, or this is, you can take it as x1, this is, you can take it as x2 and all. Here I have taken it as w of n, It is equal to n into minus 0.5 to the power n u of n. Okay, first I will take the z transform of this. As we know that the minus 0.5 to the power n u of n, z transform is given by z divided by z plus 1 by 2 or 0.5. Same, z divided by z plus 1 by 2. With ROC is mod z is greater than 1 by 2. Because it is a right sided sequence, the ROC will be greater than 1 by 2. Now you know that the z domain, the differentiation property in a z domain is given by, that is n into x of n, z transform is minus z into d of dz by x of z. So it's a differentiation property of z transform. I'll use this because this signal is multiplied at the n. Right? So I consider w of n is equal to n into minus 1 by 2 to the power n into u of n. That is z transform is w of z is given by minus z d by dz, z divided by z plus 1 by 2. Here I will apply u by v rule. The u by v rule, and I write it as minus z, z plus 1 by 2 minus z divided by z plus 1 by 2 whole square. So after simplification, I'll get minus 1 by 2 into z, and it cancels. I'll get minus 1 by 2 into z. Denominator I'll get z plus 1 by 2 whole square. With ROC is mod z is greater than 1 by 2. So I obtain the z transform of the first term. Now similarly, I'll obtain the z transform of the second term, that is 4 to the power n u of minus n. I'll consider, we'll find the z transform of y of n. It is 4 to the power n into u of minus n. Now here you can observe u of minus n is there. If it is a minus inside the bracket, means you can use a time reversal property. To apply a time reversal property, wherever n is there, that should be replaced by minus n. So in this equation 4 to the power n is there. This is positive here, but as here it is negative. So I'll change this as negative. I can take it as 1 by 4. 1 by 4 to the power minus n is equal to 4 to the power n. Right, into u of minus n. Now by using the time reversal property, we know that we can write 1 by 4 to the power n u of n is z transform z by z minus 1 by 4. The ROC is mod z is greater than 1 by 4. Now I'll use the time reversal property here. X of minus n at z transform is x of z inverse or x of 1 by z. Therefore y of n at z transform is y of z. So I'll replace this z by z inverse or 1 by z. So z inverse divided by z inverse minus 1 by 4. The ROC is 1 by mod z is greater than 1 by 4. So I'll simplify this, 1 by z divided by 1 by z minus 1 by 4. And here I'll get the answer as minus 4z divided by z minus 4. With ROC is mod z is less than 4. Right, with mod z is less than 4. So now I obtain the z transform of both the terms. One I taken as y of n, other one I've taken it as w of n. So finally we'll apply the convolution property to obtain x of z. So we know that the convolution property is defined as the convolution of w of n and y of n. Z transform is w of z into y of z. So it is a multiplication. With ROC is the intersection of ROC of w of n and ROC of y of n, that is RW and RY. So I already taken this, I will write this directly, minus 1 by 2 into z divided by z plus 1 by 2 whole square. This is my w of z into minus 4z divided by z minus 4. So this is my y of z. So I'll multiply this, I'll get the answer as 2z square divided by z minus 4 into z plus 1 by 2 whole square. So this is the final answer, x of z. With ROC is intersection of the first signal and second signal. It is so mod z is greater than 1 by 2, at the same time it is less than 4. So here I used the properties of z transform. I used the differentiation property time reversal property. Finally, I used the convolution property. So the next problem is find the Z transform of the following signal with x of n is equal to 2 to the power n u of minus n minus 3. And second problem is x of n is equal to sine pi n by 8 minus pi by 4 into u of n minus 2. And this question is also appeared in the model question paper. And here x of n is, we'll solve the first one here. X of n is 2 to the power n u of minus n minus 3. So I have to obtain the Z transform of this. So either I can use the properties of Z transform, or I can use or I can solve directly, because they are not mentioned. You have to use the properties of Z transform here. So if it is easy to apply the properties, then you can apply the properties, then you can obtain the Z transform. No problem. So here x of n is 2 to the power n u of minus n minus 3. Now I'll obtain the Z transform of x of n is given by x of z n for minus infinity plus infinity x of n z to the power minus n. Now you know this, what is u of minus n minus 3? It's defined from minus infinity to minus 3. It's a left sided sequence, starts from minus infinity, ends at minus 3. So I'll write the limit as summation over n from minus infinity to minus 3, 2 to the power n z to the power minus n. So I interchange the limit, that is n from minus 3 to minus infinity, 2 to the power n z to the power minus n. Just interchanged it. Then I'll write 2z inverse to the power n. Now I'll change this sign. I want this as a positive. So I'll change this sign. Put n is equal to minus n. I'll write n is 3 to infinity, 2z inverse to the power minus n. Or I can write this as summation over n from 3 to infinity to inverse into z to the power n. Now I'll make this 0. This term as 0. For that I'll consider put m is equal to n minus 3. From this I can write n is equal to m plus 3. Now put the lower limit in this, that is n is equal to 3, we'll get m is 0. Put n is equal to infinity, we'll get m is infinite. Therefore my x of z, I'll get this equation, that is summation over m is equal to 0 to infinity 1 by 2 z whole to the power m plus 3. So in this way it can change, and it can bring it to the standard form. So instead of 3 to infinity, I just change to 0 to infinity. The variable I am using now here, yeah. Now I'll take the constant term outside. You'll get 1 by 2 z to the power 3. And summation m is equal to 0 to infinity 1 by 2 z to the power m. And 1 by 8 z cube into 1 by 1 minus 1 by 2 z. And I'll take this 1 by 8 z cube divided by 1 minus 1 by 2 z. So this is my signal. And I'll write the ROC is mod z is less than 2. Because if we'll take this particular term, then I can write the ROC as mod z is less than 2. So this is a ROC for the problem. And the second problem in that, the x of n is equal to sine pi n by 8 minus pi by 4 u of n minus 2. And here this signal can be written as x of n is equal to sine pi by 8 n minus 2. If I take pi by 8 outside here, then I can write sine pi by 8 n minus 2 into u of n minus 2. Correct, right? So now you observe here u of n minus 2 is there, and here also n minus 2 is there. So you can use a time shifting property to obtain the answer. Otherwise this problem will be more complex. If I solve by using a direct method, it will be more complex. So therefore first I'll obtain the z transform of sine pi by 8 n into u of n, then I'll apply the time shifting property. And if we are able to remember this equation, that z transform sine omega naught n into u of n, z transform is sine omega naught z inverse divided by 1 minus 2 cos omega naught z inverse plus z to the power minus 2. So this is one of the standard signal, sinusoidal signal. And I solved this problem in one of the classes. And here the mod the omega naught is, I can take it as pi by 8. So I substitute that pi by 8, sine pi by 8 z inverse divided by 1 minus 2 cos pi by 8 z inverse plus z to the power minus 2. So therefore, using time shifting property, I'll write sin pi by 8 n minus 2 d of n minus 2 as I'll multiply with z to the power minus 2. You know that time shifting property is x of n minus n naught z transform is z to the power minus n naught into x of z. So here u of n minus 2 is there. So this u of n is replaced by u of n minus 2. So I'll take it as z to the power minus 2 multiplied to this sin pi by 8 z inverse divided by 1 minus 2 cos pi by 8 z inverse plus z to the power minus 2. So sin pi by 8 I'll get 0.383 and the cos pi by 8 will get 1.848. Substitute that, we'll get the answer as 0.383 z to the power minus 3 and multiply this. Denominator will get 1 minus 1.848 z inverse plus z to the power minus 2. With ROC is mod z is greater than 1. And here in this problem, if it is not able to remember, if it is not possible to remember this equation, means you just solve by using a direct method and obtain a z transform this, then you can apply the time shifting property. In this way also you can solve it. So these are some of the problems, theory questions which is appeared in the model question paper. Then in the state and prove the following properties of the transform. It appeared in model question paper 2, and explain this in the properties of the transform class. The one is the time reversal, the other one is multiplication by exponential function, or it is also called as scaling in z domain. Scaling in z domain. So time reversal function, you know that that is x of minus in z transform is x of 1 by z, and scaling in z domain is you can take the equation as a to the power n u to the power n into x of n. Z transform is x of z by a or alpha, same. So this is a theory question. And similarly, they asked what is region of convergence. The ROC of Z transform, mention its properties. They have to define what is region of convergence and explain in the first class of Z transform what is region of convergence and mention its properties. Around 7 to 8 properties are there. You have to write that properties. If they'll ask explain the properties, means just write the properties and give some examples for that. Equations. So this is about the theory question. Then one more problem, even this problem is also solved in problems on Z transform class. Find the Z transform of x of n is equal to 0.5 to the power n u of n plus 2 to the power n u of minus n minus 1. And this is both sided sequence, the example. Here this is the right sided sequence, this is the left sided sequence. You just obtain the Z transform of this, obtain the Z transform of this particular equation, and one will get ROC right sided, that is greater than condition, other one will get less than condition, combine it. So the ROC will be a constant ring you will get. This type of problem is solved. And the last problem also, you can take this as an assignment, you can solve and you can submit to us. You have to determine the Z transform and ROC for the following signals. Sketch the ROC, poles and zeros in the Z plane. Say here x of n is equal to 2 to the power n sin pi by 4 n into u of minus n. Second problem is x of n is equal to 1 by 4 to the power n u of n minus u of n minus n. The first problem is same type of problem is solved. I have just taken it as n into sin pi by 2n into n u of minus n. So here instead of that, here sin pi by 4n is there. Instead of n, here 2 to the power n is there. Now again, this problem we can solve by using the properties of the transform. The first you obtain the Z transform of this particular term, that is sin pi by 4n into u of n, that is sin omega naught n into u of n. Here you can apply the time reversal property because u of minus n is there, and here you can write this as minus here, no problem, because minus sin pi by 2 minus n you can write, And this 2 to the power n, you can write it as 2 inverse to the power minus n. So it is 1 by to the power n into n. So in that way you can solve it. By using the properties of Z transform, just obtain the Z transform this. The second problem, this is x of n 1 by 4 to the power n, u of n minus u of n minus n is there. And here, this signal duration is from 0 to n. So 0 to capital N. So in the summation, we'll get from n from 0 to capital N, 1 by 4 to the power n into z to the power minus n. So use the standard equation. This is a finite series you will get, and use the standard equation and obtain the Z transform this. I think the same type of problem is solved in the textbook. Instead of n here 10 or 9 is given. Just refer that and solve this. So you can take this problem, 2 problems as an assignment, and solve this, and you can submit it. If you have any doubts, you can check the answers. So this is about the problems of model question papers, and I solved some of the problems in problems on inno-Z transform in the inno-Z transform classes, 2 classes. The one problem is asked on partial fraction, other problem is asked on the power series expansion method. And these are the 2 theory questions they asked. What is region of convergence and of Z transform, mentions properties, and study and prove the following properties of Z transform. So this completes your module 5, the Z transform. So I have solved many problems on the problems of Z transform, then problems on inner Z transform, then transform analysis of LTI system and all. So to summarize the Z transform class, that is module 5. So you started with the introduction to the Z transform, definition of Z transform, ROC, properties of ROC, then properties of Z transform, then problems on Z transform, problems on properties of Z transform, inno Z transform is partial fraction method, power series method. In the last class we discussed about transform analysis of multi system. In that, transfer function, solving difference equation, then checking the causal and stable condition. For that we are finding the impulse response and all. So, thank you.